Today we will talk about the circuit composition and working principle sequence of the entire motherboard of the laptop. There are two main parts of the laptop bootloader sequence. One is called the hard boot of the computer and the other is called the soft boot. Regardless whether it is a desktop or laptop, its startup process will not change. Hard started from standby until reset generation. What is the name at this stage? Hard start phase. And our soft start includes two circuits of BIOS and interface connector to complete. Generally, there will be more failures of the hard start and less failure of the soft start. But it is also very important. So what are the processes for hard booting of the computer? First of all, when it is in standby, it is completed by the protected isolation circuit and the 3V and 5V standby circuit. The first stage is completed by these two standby circuits. Then after standby is normal, we enter the second trigger state. The trigger circuit is clicking the switch to notify the EC to work. The process is called the trigger circuit. After the trigger circuit works, go to the next stage of grouping power supply circuit. The packet power supply circuit is divided into RAM power supply, bridge power supply, and graphics card power supply. The packet power supply is divided into these major blocks, including these three power supplies. After the grouping power supply, the fourth step is to power the CPU. Then the fifth is the clock circuit. The sixth is the reset circuit. In other words, entire hard boot process, from the standby process to the completion of the reset. To reset the CPU, this is the whole process. Then after the soft start, after the reset circuit is the BIOS circuit. The seventh is the BIOS circuit. The eighth is the interface connector circuit. Number 7 and 8 circuits are soft start stage. The first 6 circuits belong to the hard start phase. Generally, the hard start is more likely to fail. In other words, there are currently several major circuits, 2 standby circuits, 1 trigger circuit, and its power supply. There is also a big circuit, the charging circuit. Charger laptop battery, plus the circuit. There are also RTC circuits, circuits for storing information. Overall, our laptop has several large circuits to complete. Let's take a look. Hard start includes 11 parts. In other words, 11 circuits are used to complete the entire laptop workflow. Generally, the damage rate of the previous hard start is relatively higher. The focus of our study is also graphs here. These are starting circuits of the computer. If we had to figure it out, especially the protection isolation circuit, its damage rate is relatively high. Whether it is an Apple laptop or Windows laptop, it is also focused on learning. Different brands of laptop focus on different protection isolation circuit. The rest of the circuit works the same. We learned the Apple laptop circuit, including Windows computer, can also be paired, and the hand skill part are same and easy, right? The main part of the BIOS circuit is flash the BIOS. If a laptop does not turn on, if any of those circuits in it is broken, it may be not turn on. So when we are repairing, according to the curve of the DC power supply to reduce the scope of repairs, to determine which circuit is faulty, this is the top priority. These are major circuits of the laptop. We need to figure it out. Protection, isolation, standby, trigger. The so-called trigger is clicking switch. We press the switch and let go. The process is called the triggering process. This point must be clear. In other words, what's the first thing we check if the computer is not turned on at the beginning? The first check is the hard boot, and then the soft boot. It's a problem with the hard boot or the soft boot, determined according to the current. In hard boot, standby, trigger, and grounding power supply are relatively easy to break. The soft start is relatively mild, and the bridge is easy to break. Its focus is different. These two steps need to be clear. Today we are talking about the standby part of the Mac. It contains several parts. Part 1, 3 voltage. It mainly contains the first voltage, PP3V42 G3H, which is the first to work. For Apple laptops, no matter which style, it is the first voltage circuit. The circuit we learn first. The second one is PPVBUS G3H. By analogy, we'll talk about the circuit generation of this voltage, which is our common point voltage circuit. Then the third one is our 3-volt standby circuit. We will tell you every circuit in this order. As long as any voltage of each circuit is broken, our computer will not turn on. Then its order also works first in this order. This first knowledge point, the 3 major voltages. Second, we will also talk about the 4 major conditions of EC. Third, 11 standby conditions of sub-bridge PCH. In other words, before a laptop is turned on, this part must be work first and work in order. This is standby state of our Apple laptop. No boot, but we have to check this all first. Then before checking, we need to explain the principle of this circuit to you clearly. And we'll be able to measure, find this related circuit and software on the board. So next, we first talk about the PP3V42 circuit, how its voltage is generated. So first, let's talk about the standby voltage of PP3V42. On the laptop, it outputs from the power supply through a regulator to output 3.42 volt. So on the board, we must first find this voltage regulator. All Apple laptops must have this circuit. It's also the easiest circuit. It is a small voltage regulator. So who does it generate 3.42 volt for? It's mainly for the EC and later hard disk. It's also relatively easy to break. Then we find in the circuit diagram how this 3.42 volt circuit works. How to send it from the adapter power port to the regulator and the output from the regulator. Let's take a look at how this circuit is generated on the circuit diagram. Then let's talk about how the 3.42 volt circuit is produced. Take a look, it has a boost inductor. We first test whether the inductor is 3.42 volt during maintenance. Its voltage is mainly generated by the U7900 regulator. It's also during maintenance. First of all, is there 3.42 volt on this inductor? We know if the regulator circuit is damaged. So how does this regulator work? Let's move it over to see how it works. This regulator first needs to input an 18.5 and 14.5 power supply. It is sent by the power supply. Some of our adapters are 18.5 and some are 14.5. However, most of the current new machines are based on the 14.5. Then after it has a power supply, it will have a switch signal in the second step. Let's take a look at the switch signal coming in. With the switch signal, our fourth pin is to output a square wave. We use an oscilloscope to measure it. It is a square wave. It first outputs this square wave. This is the third step. It is our 4th pin and its power is input from the 6th pin. The switch is input by the 3rd pin. Input square wave at the 4th pin to control the charging and discharging of this capacitor. Power a boost module. This is our 4th measuring pin. In other words, during maintenance, if we measure there is no 3.42 volts on this inductor, it may not be that this regulator is damaged. You must first test whether the original part and input part of the regulator is normal, including the power supply of the 6th pin, the switch signal pin of the 8th pin. If both voltage come in, there is no square wave output. We can be sure that this regulator is damaged. Then there is a FB pin on the first pin here. It serves as a kind of feedback when working, which is our feedback pin. Our 5th point is the last step. The 5th point is the feedback pin. Let's take a look at this resistor as 2 resistors. We also talked about it in the basic course. One is grounded, called pull-down resistor, and another one is called pull-up resistor. The damage of these 2 resistors will cause the 3.42 volt voltage of this inductor to fluctuate. It is smooth direct current, so the resistance of these 2 resistors must not be deviated. 1% of the circumscript on this picture here. Points to be emphasized here. First, this resistor is indispensable. Second, the inductor cannot be short circuit. It adds a booster and cannot be short jumper. There is also the capacitor of C6994. It is indispensable and cannot be short circuit. It should be noted that many problems cannot be solved when placing the voltage stabilizer during the maintenance. You won't check the small components, including the components such as C6994 and L6995. And our component C6995 is a capacitor. Play a kind of filtering function of charging and discharging. This is indispensable. So everyone take a look at this voltage regulator. Then if we find our 6-pin VIN pin during maintenance, Without 40.5 or 80.5, how did this circuit come about? Let's look up again to see which circuit it is generated from. Let's take a look, move it over. This 14.5 is through a rectifier diode. This 6905 comes from this diode. In other words, our VIN pin does not have 14.5 volts. We must first measure whether the diode is damaged. If the diode is not damaged, let's take a look at the anode of the diode, which is the anode of the diode. The voltage of positive pole enters from the positive pole, which acts as a rectifier, and the negative pole comes out. Then it has a resistance of 10 ohm, and this resistor cannot be shock jumper. Only the original value with 5% replaceable error. This resistor plays a protective role and insurance role. Remember R6905 this resistor. Then from the input of the R6905, we can zoom out to see. Let's take a look and they connect to another Q6910 MOSFET. His electricity goes from this pin to the S pole. Everyone, let's see it goes from here. Going by this pin, comes out by this pin. Take a look, this pin comes in. Let's take a look at this arrow. After it comes out, it will be sent to our 6905 resistor. In other words, if the resistor is not damaged, we will find our Q6910 next. Its electricity is progression, deeper out. So where does the S electricity comes from? Let's take a look. This is our power interface, that is, the information interface. The power of the adapter interface passes through the PAVE. Send to our Q6910's S class and then output from the D class. Send to our 6905, send to the anode of the diode. The output from the cathode of the diode is sent to the input of our U6900 regulator. In other words, if there is no voltage at this input, we have to pass the bitmap. Find these components in the bitmap and measure their quality to determine whether there is a problem with the input circuit. Remember here. Let's take a look at this switch signal pin and input pin. They are connected in parallel. It is also entered from here, so we won't do much analysis here. Look at the picture marked 18.5. It comes in as 18.5 volt. Some drawings are now the new version. It is 14.5 volt. In this position, you see it is 40.5 volt, some are 80.5 volt. So if we measure the whole way, we'll emphasize one more point in the maintenance. We are repairing in this field 2 MOSFET is damaged. We not need to replace it. D pole can be given to the S pole. We use tin to shock jumper these 2 pins. Just omit the word of this circuit. It's also a speculative exercise and it's also a quick fix. This MOSFET can be shorted, but not warmly connected. Be sure to shock jumper the D pole and S pole. This is how U6990 generates its first 3.42 volt voltage. There are also 18.5 volt. You have to see the picture of detail. Our drawing is 80.5 volt and some drawings are marked with 14.5 volt. So this is a working principle of the circuit. This circuit is relatively easy to repair and it is very easy to break. When our laptop does not turn on, the first thing to detect is this circuit. Is there 3.42 volts on this inductor L6995 and it is also the first test point. So let's talk about how to repair this 3.42 volt during maintenance. A small summary of these techniques. How to repair this 3.42 without voltage. In this, we generally need to check the value of it first. Dial value of the L6995 with inductor. What are the two situations? Shock to the ground. We also talked about the ground resistance in the basic course. I hope that when you are learning, you should also review the content of the basic course. One is short circuit to ground, 0, 0. One is open line, OL, open circuit. And the other is connection. That is to say, the dial value when it is short circuit and the multimeter shows 0. It is not the damage of this regulator, but the leakage of this after-stage circuit. Generally, we use burn to fix, add a big power on this line, like the shock killer. Most of them are capacitor or easy damage a little bit more. If there is an open circuit to the ground, it is generally OL. This situation called an open circuit. If there is an open circuit, it is usually disconnected. Either the bottom of the chip has dropped past or disconnected or loosened. To jumper or boiling the chips, we need to use jumper wire. This cutoff probability is not high. This cutoff probability may be relatively more for that kind of heavy form machine. There are not many cases of normal damage from experience. Most of them are short circuit or have a few hundred ohms to ground. In the case of the few hundred ohms, we usually change the chip and the voltage regulator, which is connected to this line first during maintenance. This 3.42 volt regulator is mostly damaged. So if it is not good after changing the voltage regulator, how can we repair it? We need to open the drawing to find. We just saw the VIN pin on the drawing in the circuit diagram. It should be 18.5 volt or 40.5 volt depending on the picture. Is there any problem with the circuit on this pin? If there is no problem with this circuit, immediately check our SD pin. SD pin can be seen in the picture. It has not passed any components. There is only one possibility, disconnected. We make a jumper here from this pin. If you have both normal value on these two pins, you have to check if it has a square wave output. Our third pin square wave. This is a voltage regulator. This detection pin needs to be detected. Then detect our FB pin. This original needs to be checked carefully. Boost capacitor, boost pin must be checked. In other words, if you measure the inductor, there is no voltage, and the resistance value is applied to the inductor. There are several maintenance methods. So this is a step of our 3.42 volt repair. First of all, we must set the resistance value to the ground. We don't boot. The first test point is at this point. See if there is a voltage. There is a voltage. It means the circuit is normal. The above is the principle of our 3.42 volt generation.